Hello, this is John from GEDMathLessons.com. I'll tell you a little bit more about my free GED math course at the end of this video. But this particular video is going to focus on triangles, okay? And I'm sure most of you out there know what a triangle is. I have kind of a sketch of one here, but what I want to do is explore the various mathematical um, components of a triangle. And there might be more than meets the eye for a lot of you out there. I'm sure most of you have a basic sense of some triangle relationships, or maybe you don't, but you're going to learn a good amount in this video. So we'll try to make it short and focused. But with that being said, let's get right to it. Okay, so maybe it's a little pop quiz. I would encourage you maybe to pause the video and just write down, what do you think you know about a triangle? Okay, like facts or different parts of the triangle, etc. Let me just kind of, test yourself real quick. All right, so you didn't have to do that, but if you wanted to do it, it's kind of always a good check on your current level of understanding. But let's first talk about the parts of a triangle, some of the kind of nomenclature terminology about the triangle. Then I'm going to give you some specific formulas and properties about a triangle that are going to be really important for you to know for the GED. Okay, so a triangle is technically a three-sided polygon. So let me just write this down here, polygon. You can take notes if you want, not necessary, but a polygon in geometry is a figure that we can construct from straight lines, and it's kind of closed in. So in other words, a triangle is one, okay? A square or rectangle would be another. Then we can construct a pentagon, etc. So the first polygon that we can construct is a triangle. So a triangle is a type of polygon, okay? Just as a square or rectangle, etc. Now, a triangle has these three corners here, okay? These corners are referred to as a vertex, okay? So this is one vertex, and then multiple vertices would be the plural. Now, in geometry, we like to kind of label triangles as well. A very common way of doing that is we label the vertices, the vertex points. So here I can call this A, B, and C. So I can define this triangle as triangle. We draw a little triangle A, B, C. Okay, so triangle A, B, C. That's one way of kind of naming a triangle. Probably the most common way of doing this in geometry. Now, these parts of the triangle here on the side, these are called the sides of the triangle. Okay, so this is a side. All right. And we see we obviously have three sides. Now, let's talk about angles in a triangle. Okay. Now, angles are these measures right here. Okay. Now, an angle of a triangle can be anywhere from, well, it's going to be less than 180 degrees. All right, but it's got to be more than 0 degrees. Okay, now degrees, just so we know, let's just kind of review this, because I don't want to assume, I want to kind of just start from the most fundamental type of thing. So we have this little nomenclature here, degrees. And what does that mean? Well, if you look at a circle, okay, we kind of start from the center here, and just kind of think of it as almost like a clock. Okay, so I have like the faces of the clock here. All right, and as this thing kind of swings around the clock, we can kind of think of this as degree measurements, okay? So right here is 0 degrees. If I go over to the right, just like so, okay, and form kind of like a corner of a square, that's 90 degrees. If I go another 90 degrees this way, I'm at 180 degrees. So from here to here is 180 degrees. Now, if I keep going to this point, let me use a different color here. If I go from here all the way over there, I added another 90 degrees. So I'm landing at 270 degrees. And the degree, when I'm talking about the angle measure, Okay, I use this little degree. It's a little small circle above the number. And then last but not least, a full complete rotation around a circle is 360 degrees. Okay, so you kind of think of it as reference points of like say north, south, east, and west, right? So if this is north, zero, I'm going 0 degrees. If I'm going due east, I would be going 90 degrees, and due south would be 180 degrees, and due west 270 degrees. Now, this is how airplanes and ships kind of navigate with this kind of degree reference. So just so you have an idea of what a degree is, this is the way we measure angles. Okay, so the thing about a triangle, and this is really important, so let's kind of put a little flag here, is that the sum of the angles in a triangle, in other words, if I take this angle and I add it up to this angle, I add up that angle, no matter what triangle I have, the sum of the angles is always going to be equal to 180 degrees. This is extremely important for you to remember, okay? No matter what triangle, if I add up all 3 angles, I'll always get to 180 degrees. So that's going to help us out. So for example, let's say this is 30 degrees, and this is, let's say, I don't know, let's say 40 degrees. Okay, so if this angle is 30 degrees and this angle is 40 degrees, what would this angle measure be? Okay, well, you can see here I have 70 degrees. 30 plus 40 is 70, right? And I know that there's 180 degrees total. So the missing angle, okay, would have to be what? 110 degrees, right? So you just subtract the 70 from the 180, and this is how we find missing angle measurements in a triangle. So really, really important for you to note that, okay? Now, one of the ways some of the notation that we use for angles, this is different ways, but in geometry, one common way would be the following. Okay, so let's talk about this 30-degree angle right down here. Okay, so I wanted to talk about that in geometry. We use this little angle measure. Okay, and this angle here is formed by the side B to A and then A to C. So I would call this angle BAC. Okay, angle BAC. Now, the vertex, okay, it's important that it's in the middle here. You wouldn't call this ABC, okay? Specifically, you have to go in order. So BAC. So angle BAC has an angle measurement of 30 degrees, okay? Now, in geometry, the measurement of angles and lengths. Very often we use this other symbol. Okay, this is equal, but you might see this as well. That's congruent. It just basically means it has this particular measure. Okay, so this is how we kind of describe angles. Okay, and define a triangle in geometry. All right, so we've already kind of covered probably a lot. A lot of it's notation, but I would say this right here is also extremely important. The sum of the angles of some of the angles of a triangle are 180 degrees. So let me go ahead and erase this. And by the way, I like to start from the beginning and not assume that that a student already knows this stuff. And by the way, if you didn't know it, don't feel bad. It's like, hey, unless you're studying this material, you're not going to really, be talking about triangles every day of your life. So this is why I'm doing this review. Okay, so some of the angles of a triangle 180 degrees. Now, there's different type of triangles, and this is something that's very important for you to know as well. So let's just kind of write some names down here. So we have obtuse, we have acute. Hold on here. I'm kind of messed up my spelling. Acute. We have a right triangle. We have something called scalene, and hopefully I'm getting the spelling right on all these guys. And let's see here, isosceles, and I definitely will mess that up, so I'll abbreviate. And there's another one too, equilateral triangle. Okay, so there's different types of triangles out there. Now let's just kind of talk about these real quick, just in case you're given a description of it. Say, hey, listen, we're talking about an obtuse triangle or an acute triangle or a right triangle, etc. So these are various types of classifications of triangles. So the obtuse triangle, okay, has one angle that's more, okay, that's greater than 90 degrees. Okay, so one of the angles in the triangle is greater than 90 degrees. So this example here that I just wrote, or just drew out here, is an obtuse triangle because this angle here, angle B, and by the way, another way we can refer to this angle is angle B. Okay, so that's another way. So both notations are common in geometry, but if one of the angles in the triangle is greater than 90 degrees, we can classify that triangle as obtuse. Okay. Now, acute triangle is that all of the angles are less than 90 degrees. Okay, all of the angles are less than 90 degrees. So that might be something like, let's say, let's kind of make up an example. Let's say 70 here. Let's put, say, 60 here. So that gives us what? 130, right? Oops, draw that a little bit better. So 60 and 70 would be 130 degrees, so this guy down here would have to be 50 degrees. Okay, so all these angles here are less than 90. That type of triangle we would refer to as acute. Okay, right triangle is one of the angles is equal to 90 degrees. Okay, equal to 90 degrees. Now that would look something like this. Okay, kind of draw it out, and these are very important triangles here. Right triangles. We study these pretty in depth in geometry. And this little notation here looks like a box in a corner is the angle that is exactly 90 degrees. This is a right triangle. These type of triangles have some very unique properties about them, okay, and formulas. I'll get into this maybe a little bit later in this video. Again, already you're saying, well, triangles, what am I going to learn about triangles? I already know what a triangle is. Well, it's a big part of geometry. Triangles, there's a lot of things in there. So trying to kind of review all, the basics of this, somewhat quickly, but it definitely deserves your attention and further study, okay? All right, let's talk about scaling, all right? Now, a scaling triangle is where all the sides are not equal. So basically all sides have different lengths, okay? Different lengths. All right, so something like this. Now we're not talking about angles. We're talking about the lengths of a triangle. So something maybe along the order of this being 9, this being 5, and this being 12. Okay, so it could be 9 inches or 9 feet. Doesn't make a difference. But all the sides of this triangle are different lengths. That is a scaling triangle. Okay. Now, an isosceles triangle is two sides, okay, are equal, okay, equal length. So let me kind of sketch out something like that over here. That would look like maybe something like this, where this would be 15, and this would be 15, and this can maybe be 7. Okay, so both sides are equal. Now, in geometry, there's a notation for showing equal sides. If I put a little hash mark right there on this side and another little hash mark there, this is a notation that indicates that these two sides are equal measure. So if I got rid of the 15 on either side, you can still see here by this notation that these sides are the same length, okay? So that would indicate that it is an isosceles triangle. Now, the important thing about isosceles triangle as well is that these angles down here, these base angles are the same, okay? Same angle measure. So, for example, this could be 70, and this would be 70 degrees as well, okay? All right, let's finish this up with the last one. That's equilateral, and that is where all three sides are equal. And it's all three sides and all three angles, by the way. So let's just going to sketch that out real quick. All right, so let's show that each side is equal to one another, side, side, and side. So this could be, let's say, 8, 8, and 8. and each angle measure is equal. So you think about that for a second, it's got to be 180 degrees, so divide that by 3. That's a 60 degrees, 60 degrees, and 60 degrees. All right, so that's an equilateral triangle. So classifications of triangles are important, right? Now, let me go and let's talk about a couple things here. And again, this is no substitute for a full lesson on triangles, but I am trying to get you to be mindful that this is a pretty big topic. I want to talk a little bit more about right triangles, okay? And then I want to talk a little bit more about some triangle inequalities, and I'll get to that in 1 second here. Let's see here, 9. Draw a little bit better triangle. Okay. 5, 9, and 12. We'll get to this in a second. Let me go ahead and handle this one first. So this is a right triangle here, okay? Right triangle, right? Because one of the corners here is 90 degrees. Now, let's suppose this side is 3, this side is 4, and I wanted to know the length of this side here. Well, if you have a right triangle, you can use something called the Pythagorean theorem. And it says a squared plus b squared equals c squared. And you're like, well, what is that? Well, that means this, that these sides here, A and B, are the lengths of the smaller sides. C is the longest side. We call that the hypotenuse. So we can figure out what the longest side is of a right triangle, only a right triangle, and it's indicated by this notation here that this is 90 degrees, by doing the following. I can take a side, let's say this is 3, and we're going to square it, plus this other length, okay, and that's 4 squared. That's going to be equal to c squared. Now, c is always the length of the hypotenuse. Now, we don't know that, but let's go ahead and just follow this math out real quick. So 3 squared is 9, 4 squared is 16, and I'm looking for this side, c squared, okay? So when I do that, I get 9 plus 16 is 25. So 25 is equal to c squared. So to solve this basic equation, something squared is 25, we just simply take the square root of both sides, and the square root of 25 is 5, okay? So the square root of c squared is c. So c is 5. So in other words, this length right here is 5. This is a very, very quick introduction to the concept of the Pythagorean theorem, but absolutely critical that you understand this. Again, I'm going to leave you some with some follow-on guidance at the end of this video. So just remember, again, this is just an intro to the concept of triangles. Now let's go over here and talk about the triangle inequalities and something else. Before we do triangle inequalities, let's talk about the area of a triangle. Okay. So if I wanted to find the area of the triangle, okay, the area is like how much. Let's just think if you had like wrapping paper and you wanted to like figure out how much wrapping paper you needed to cover this triangle, that's the concept of area. So the area of a triangle is 1/2 base times height. Now the height of this triangle, we can measure it in different ways. If this triangle was kind of sitting on a table like this, let's imagine this was a table, this right here would be considered the base, 12. All right, so what would you consider the height of that triangle? If this big triangle is sitting on your table, right, what would you consider the height? Well, most people would say, well, it's this tall, and you would be correct. So the height would be this measurement here. So that might be, in fact, let's say 3. Let's just make up a number. So the area of this particular triangle would be 1/2 the base, which is 12, times the height of 3. Okay, so we could simply just do this math real quick. So this would be 6 times 3, which would be 18. Now, if these are, let's say, inches, area is measured in units squared. So this would be 18 inches squared. Okay? Again, I realize I'm covering a lot in a short period of time, and it's definitely necessary for you to follow up. But, I want you to get a real respect for triangles other than they're like these, little polygon type things. There's a lot to them. Okay. All right, let's get into triangle inequalities real quick. Now, this is really interesting as well. So one of the unique things about triangles is the following. If you take two sides of a triangle and you add up those two sides, it will always be greater than the third side. So for example, let's say these are the measurements of my triangle, 5, 9, and 12. If I go 5 plus 9, that number is always going to be greater than 12. It has to be if it's an actual triangle measurement. So I can see here that I got 14 is greater than 12. That checks out. But now let's kind of, do some other sides. What if I, hold on one second. What if I did these two sides, and let's see if that's greater than this side. Okay, so no matter what two sides, it will always be greater than the third side. So let's say 5 plus 12, is that greater than 9? In fact, it is, right? So I got 17 is greater than 9. That checks out. And then let's see here what combination we haven't done. Lastly, 9 and 12. So 9 plus 12, is that greater than 5? In fact, that's 21. 21 is greater than 5. Now that's important to know because you might be asked on a question like if you had 3 lengths. Here, let me just go ahead and just erase this here. Let's imagine you had 3 straight sticks or straws or whatever you want to call them. Let's just, you can kind of use your imagination. Let's say I had something like this, I had something like this, and then I had something like this long. And I said, can you form a triangle with those 3 straight items? So you would say, yeah, you might want to manipulate them around. You might take this guy right here, right? And say, okay, let me put that guy right here. And then, here, let's get this guy out of the way. But you'd be stuck with this, right? You'd be like, well, I can connect that down here, but that's not a triangle. That looks more like an arrow, right? The triangle, has to reach this corner. So if you give me these 3 lengths, this guy, a length like that, and there's no way I can build a triangle. I'm going to end up with some sort of arrow figure, okay? So typical questions are going to be like, hey, could you build a triangle from these 3 lengths? And it's the concept of these triangle inequalities I just went over that will tell you, hey, yeah, if you can add up any 2 sides of the triangle and it will be greater than that third side, no matter what combination, then in fact you can actually build an actual triangle. So there's so much more to learn about triangles. And this is a good, solid introduction, okay? And your head might be spinning a little bit. I can certainly appreciate that. But let's go ahead and wrap it up from now. So if you enjoy my videos, I hope you would consider subscribing. Don't forget to hit that notification bell on your phone or your computer so you can get alerts to my videos. I'm doing videos I do videos pretty much weekly, just because I just feel so passionate about getting information out there, education for those of you out there that are studying for these tests. If you like the video, hey, give it a thumbs up and, leave me some feedback. I try to read as many comments as possible so I can figure out what you're looking for. But last but not least, I want to leave you with my free GED math course. It's at gedmathlessons.com. So this is really going to be a good, solid, extensive course. It covers algebra, geometry, really give you a solid foundation. It's had an outstanding record for people, that need to kind of upgrade their math skills for the GED. So definitely invite you over to that. I'll leave the link in the video. But again, triangles, like anything that seems kind of simple in math, circles, triangles, and stuff, there's generally a lot going on. And I wouldn't feel comfortable for you just to watch this video and feel like, oh, okay, I know everything about triangles. You need to learn a little bit more and you need to practice. So come on over to my free site. And thanks for spending a little time with me, and have a great day.